Hi everyone. This is our second video on the topic of linear signals and systems. In this video, I'm going to talk about the discrete systems part, and I will give you an overview of what lies ahead. This is the input. This is the output y of n. This is the system function h of n. Now, as you can see, we say this is this is the time domain representation, but you do not see a t. You only see the small n in this equation and in this picture here. We say that the time domain signals were discretized. We will talk about discretization in later chapters. But n here is an integer that goes from 0, 1, 2, 3, and so forth. The second representation here is what we call the Z domain. This is a frequency domain for discrete signals and systems. Capital X of Z, again, as we described in the previous video, is the Z transform of X of n. Y of Z is the Z transform of Y of n, and capital H of Z is the Z transform of H of n. And similarly, we're going to be looking at two things. First, objective is to be able to find the output y of n given an input and complete information about the system given in small h of n. When you have the input x of n and the system function h of n, we will use the convolution sum equation to find y of n. As you could see, this summation can get very, very difficult, especially when we're talking about series convergence and so forth. And so in terms of the analysis, we seek the Z transform. In the Z transform, this convolution sum in the discrete domain becomes simple multiplication, as we saw previously with the Laplace domain. And so the output y of z is the input x of z times the system function h of z. And again, once you find capital H of z, you will use tables and maybe some partial fraction expansions to produce your y of n. And so in the analysis, the objectives is really to find the output y of n. Now, talking about design again is best done in the Z domain. In the design, in a similar way, if you know the input and the desired output, what you want from the design, so we call it the desired output, you should be able to find the transfer function h of z. H of z is usually a ratio of two polynomials in Z. Once you find the coefficients for the polynomials, the numerator and the denominator for h of z, then we say that the design is complete. This is what I want to talk to you for this short video, and I hope in the later videos we can explore more topics. So have a nice day, guys. Thank you.